All right. So, coevolution. What's happening here? Huh? Oh, yeah, the bird is nectar and it's providing pollen, or the flower an opportunity to reproduce. But what is happening if it's, so that's an example of mutualism. We already went over it. Predation could be an example of coevolution too. So don't forget that there's going to be tie-ins, okay? But what is happening if species are co-evolving? That's true. That is true. So define it. Not the example, but define that relationship. Perfect. They're going to evolve to live together, evolve to change together. They are together. Now, I'm going to repeat what you said, and I said perfect, and I should have said yes, but not perfect. Because who's evolving? The population. So the species will develop adaptive traits that will tend to have them live together with the flower. But over time, the population of birds and the population of flowers evolve or co-evolve together. Okay? Don't forget that. It'll happen. Birds will reproduce to have traits that they need to live with the flower, and over time, the population, it co-evolves. Not the species. The species changes. The population co-evolves. Convergent. I have to say I'm not in love with this graphic. I kind of regret it. So I'm gonna tell you right off the bat. In convergent, there's no common ancestor. No common ancestor. I mean, it says it in the bottom, and I believe it says it here. You have different ancestors. Okay, so it should really be going from here to this. Different ancestors, and then you show common traits. Why do you think they show the common traits? Because there's environmental conditions that favor those traits. So let's add that. Physical features, I'll just make this bigger. Like the need to fly, right? Or have long wings, or you guys had this? The flying squirrels and the sugar glider. And he explained it perfectly. I'm going to replace my picture with that. I'm going to export it as a GIF and put it in there. And Noah for the McCarthy Bowl. I mean, it's perfect. Yeah. Oh, yeah, sorry. What do we start with? Common ancestor. And so the common ancestor in this case is the wolf. And then what do you think happens? How did they get there? One got domesticated. How else? If I asked you, give me an example of what could have possibly happened that could have led to divergent evolution of the wolf. Geography. Good. Right? It could be allopatric. It could be sympatric. It could be reproductive isolation. It could be any of those factors that I mentioned can impact this process. So it's all connected. We learn about what factors can influence evolution, and then it can happen. So you have the common ancestor of the wolf, and something happened. They got separated, or they were chosen to be domesticated, and over time they develop almost into a new characteristic or a new species, new population of that species. Parallel evolution. A lot of times it gets confused with convergent evolution on the exam. So convergent, you don't have a common ancestor. You have different, but the population will experience or will show similar features. In parallel, you literally are in two separate environments. Let's say this is United States, and this is, or a specific state in the United States, and this is a specific state, another state in the United States. And somehow, because of environmental conditions, you'll see the same evolutionary patterns between organisms, or the traits or the physical features of those organisms based on the environmental conditions. Now, State A and state B have the same environmental conditions. That gives rise to the similar traits. Who had this one? What pictures did you use?
I think we used a turtle. Oh yeah, the shell of the turtle and the shell of the snail.
Oh yes. So shells of different organisms in different places, but they develop the same physical features because the environmental conditions in that area are similar. So it's almost like it's based on the similarity of environmental conditions in two separate areas. Does that make sense? Whereas convergent, you have different species, so you're going to see different species in both, but it's based on one area, not separate, complete traits of different organisms. I mean, they literally will show you multiple organisms showing similar traits in that evolutionary pattern. All right, you can also see these. These are, one year this came up, and these like arrows. We had never even taught it this way, so I always include it in the notes. Who could fill in the blanks? The first one's divergent because you have a common ancestor splitting into two characteristics. Whoop. Convergent, coming together. This one? This is parallel, believe it or not. They can either show it like that, or they can show it as two straight lines. Now, this looks like parallel, but because it's showing you where I go, you go, what are you? Coevolution. It does look like it. And technically, can it be? And the answer is yes. But these are two separate environments showing the progression of evolutionary features at the same time because of environmental factors. All right, another type of evolution is called evolution of artificial selection, or you could call it GMOs. What does GMO stand for? Genetically modified organisms. How do we get genetically modified organisms? We modify the genes. What is another word that describes that? I guess, yes. But it's like done, right? How do we do this? Breeding. We selectively choose what genes we want to. I wonder, is mutation, it can happen, right? But we are selecting specific genes to create a super crop or a breed that is going to give you financial gain, right? That's really the whole point of it. It's not just animals. Like, obviously, this is high in horses and dogs, but in crops, without genetically modified organisms, we would see a big struggle in food production. Bottom line. All right, another form of evolution is evolution of resistance. And to me, this is a huge topic, super, very much. I feel like this and this are big topics in environmental science. I would say relationships between organisms, they're definitely going to come out on the AP exam, but these two are applied. We talk about this all year.
Okay, thank you.
Evolution of resistance is what? Who could fill in these blanks? Resist is a good word. I put tolerate just to change it, but tolerate, resist, fight, yes? Chemicals that are designed to do what? Kill or hurt or something. What's a perfect example of this every day? Bacteria and antibiotics. And what else? Bugs and pesticides. So you take antibiotics, let's say an example, we take antibiotics when we're sick to kill bacteria. Who could put this example and explain how bacteria can be naturally selected? Remember we said we're going to say 4 things whenever we say this story. So I have strep throat. I'm going to give you this example right here in the video. How many of you have had strep throat? Raise your hand. Yes. Okay. How many of you have taken antibiotics for strep throat? How many of you had to go back to get a new antibiotic because the first one didn't work? That was the bad strep throat, right? Or who can explain why that happened? Yes.
Because you take an antibiotic, say that 99% of bacteria gets killed, that 1% will end up reproducing and producing a new population that has the gene resistance.
She missed 1 point. The rest was perfect. What was she missing? There was variation of bacteria in your body. One of them had the favorite trait, which was fight the medicine. They reproduced offspring to now give birth to a population of bacteria that is resistant to the medicine. Ecological succession or evolution of ecosystems in a sense. Who lives in a house that has 2 acres? How about 1 acre? What's in the back part of your acre? Grass? So you live in a community that's a beautiful acre. Who lives in a farm-like acre? Nobody? Yes? What's in the back? A really big bush, okay? In my last class, 3 of them, which were the 2 acres, the back is a forest. Because you cut a specific part of your lawn and the rest you kind of just let go. And if you let go, you'll go from nothing to shrubs or weeds, from weeds to plants, from plants to pine, from pine to hardwood trees, and put the word oak there. Like an entire community will form. I'll give you a better example. Who has pavers? Pavers are like the backyard, like those pavers. Like bricks, brick pavers. What happens in between the brick pavers? If you don't cut those weeds, and tell me if this is true, because my landscaper or something. If I don't cut the weeds, what eventually starts to form from the pavers? Grass. And from, no lie. Oh, cracks? No cracks, because this happens in between the cracks. If I do not get rid of the weeds, an entire plant will form outside of the pavers. It's nasty. Or think of any property in your community that's not being taken care of. Looks like almost like a mini forest, right? Now, what you have to know, besides the progression can happen in any community, is the difference between primary and secondary succession. Primary succession, what do you see the start? Rock. And what breaks down rock? Erosion. What do we call the breakdown of rock by wind and water? Weathering. So you're going to have weathering will break down rock. And primary succession starts with no soil. If you have soil, if I get a scoop of soil, what could be in there? Worms, decomposers. There's life in soil. So there has to be a lifeless habitat, no soil, bare rock. Does that really exist?
Yeah.
Where? But is it a lifeless? What's under the rock? Soil. Yes? If you looked at the portables before they were portables, that was a vacant lot. It didn't have grass. I watched succession take place in that lot. We saw the little, like, clover-looking weeds pop up. And after mowing it, it looks like grass after a while. But grass was not planted there. Grass found its way there, okay? Where you have no soil, you're going to have weathering, but you're also going to have what's called pioneer species or primary species. And they are, anybody know what my pioneer species are? Yes. Yes. They will help form the soil. With weathering and those species, soil will form. And we'll walk out one day and look at it. From the soil, from the decomposition, from the pioneer species, grass grows. From grass, weeds. You should probably put weeds here. Weeds, then grass, then pine, then oak. Always that process. Secondary succession, soil exists or life exists, which is what happens every day. Can there be pioneer species where there's secondary succession? Yes, because there's still rock and there's still soil being formed. It happens. But same progress, it's just not a lifeless habitat to start. What if there's a volcano? Primary or secondary? Secondary. Okay? Life existed there. Soil is there. What's lava? Liquid rock, right? But was there soil there? Yes, it's underneath. Okay? And that is it.